upon twice b into t into cos a upon b into t. Okay, the last step. These are the 4 steps. Now let me solve them further. So left hand side I have to keep as they are, as it is, or left hand side is same, but right hand side. So let me put the left hand side as it is. What the right hand side here? Let me take a common from these 2 steps. So a, if I take common, 2 steps are of a and the 2 others are with negative sign of b, coefficient of b. So let me take a common. So in the first one we get positive plus plus. Okay, so this is cos. First let me write here cos a plus b upon twice b into cos t plus sine a plus b upon twice b into t into sine t. This is the coefficient of a with minus sign, minus b into within bracket. Okay, again they are cos similar type. Cos, let me write cos a plus b upon twice b into t into cos a upon b into t first, and plus sign. This is sine a plus b upon twice b into t into sine a upon b into t. Okay, so these 2 steps. Therefore, let me further solve them. Now, what is the formula here? We know that cos a cos b plus sin a sin b. It is equal to cos a minus b. Because in case of cos a minus b, it is the positive sign in between. Cos a cos b plus sin a sin b. It is equal to cos a minus b. In case of cos a plus b, it is cos a cos b minus sin a sin b. But in this case, it is cos a minus b. Okay. So first step will be cos a minus b. That means cos of a plus b upon twice b into t. This is t minus angle minus t only. Let me take t out. It will be 1 minus 1 into t. Let me write t out of this bracket. This is minus 1 into t angle. Okay. First step. Secondly, b also of the same type. This is also cos a cos b plus sin a sin b. This is b into cos a plus b upon twice b minus 1 into t. Sorry, in this case it is a upon b. I'm sorry, this is a upon b, not 1. Here it is a upon b in the second case. First case it is 1. Okay, so solving them further, it will be a into a plus b minus twice b, that means a minus b. So cos a minus b upon twice b into t. Okay, minus b into this will be twice. Okay, it will be twice b if I take LCM. So it will be minus twice a. So that will be b minus a in this case. So cos minus a, b minus a, because b is positive. B minus a upon twice b into t. Okay, what comes? This is a plus b. If I take, because it is positive, so a minus b it will be. Because cos negative sign doesn't matter, so it will be a minus b. Simply a minus b. So it is cos a minus b. So a minus b I can take common. If I take cos a minus b upon twice b into t, common, so it is a minus b into cos a minus b upon twice b into t. So this is b minus a upon twice b. No, we can take negative sign out of the bracket because cos is an even function. Cos minus theta is equal to cos theta positive. If I take minus sign out of the angle, it will be a minus b upon twice b. Okay, so don't forget this because cos is an even function. It is negative sign positive. So the same value will be here. So this is cos a minus b upon twice b. No change. Since cos minus theta equal to cos theta positive, so therefore cos b minus a upon twice b means cos a minus b upon twice b. This is the value right hand side. And left hand side we have these two steps. What is that? Cos a plus b upon twice b into t into x plus sin a plus b upon twice b into t into y equal to a minus b into cos a minus b upon twice bt. This is the final answer. This equal to this. Okay. The equation of the normal here we have calculated. Now let me solve the next question. And what is the next part? Sorry, all parts are okay. All the four parts of question number 4 are solved in this case. Now let me take question number 5 here. What the question number 5 says, let me check. Okay, so question number 5 says in this case, if Lx plus my equal to this, okay, is normal to the parabola given. Okay, so the last topic that I discussed in the definition part, that if there is an equation given of a straight line and that is claimed to be a normal to the given curve, and first we find out normal to the given curve, then compare these two normals. Okay, then comparing will give us the condition. So question number 5 in this case is, okay, this is if Lx plus my, it says if Lx plus my equal to 1, sorry, equal to 1 is a normal to the given curve, is a normal to the curve or given curve. What is the curve here? Curve here is y square parabola. Okay, y square equal to 4ax. It is 4ax. Okay, it is 4ax. Y square equal to 4ax. All right. Then prove that this equal to this. So what we have to prove? To prove, let me write to prove. What is the proof? Proof is ALQ plus twice ALM square is equal to m square. This we have to prove. Okay, to prove this. Here we are given that this Lx plus my is a normal to the given curve. Let me find out first normal to the given curve, and then we will compare this normal and to the calculated normal. So differentiating this first equation, so differentiating the equation of the curve with respect to x in this case. Okay, with respect to x, we get twice y into dy upon dx equal to 4a, only x is 1, equal to 4a. Therefore dy upon dx is equal to 4a upon twice y. That means twice a upon y only. Okay, this is the equation. Now let me take, let x1 and y1 be the point on the curve, on the parabola. On the curve means parabola in this case, on the parabola. Therefore y1 square equal to 4a x1. This will let me take second equation. An equation of the this dy dx. Therefore dy dx at the point x1 y1 is equal to, at the point x1 y1, we always calculate the value of dy dx the given point. In this case we have assumed that x1 y1 is the point given. So it will be twice a upon y1. This value is of dy dx. This is third equation. Second we have taken this. So therefore equation normal in this case. Therefore equation of the normal will be, now let me find out what is the equation of the normal then. Therefore equation of the normal will be the same formula dy dx into y minus small y plus x minus small x equal to 0. Substituting the value of dy dx and point x1 y1, it will be here twice a upon y1 into y minus y1 plus x minus x1 equal to 0. Okay, so this is the value here. Now let me solve it. So multiplying this by twice a, what do we get here? either twice a into by, let me divide it by 1. So it will be twice a to this side, we will divide, and this is y, capital Y upon small y1, this is capital Y upon y1, minus y1 upon y1 is 1, plus x upon twice a, okay, minus x1 upon twice a. Now let me write it here. This is nothing but y1 is equal to 4a x1. This we have to solve this equation, second equation. Now let me further solve it. So it will be x upon twice a plus y upon y1 is equal to, take these two, this is equal to 0, take these two to right hand side. So we will have x1 upon twice a plus 1. Okay, x1 upon twice a plus 1. So finally, this is the equation of the normal which we have calculated. Now comparing this equation, this is the third equation, let me write here. Comparing this equation of the normal which we have obtained, the given curve, to the given equation of the normal, to the given equation of the normal is what? Lx plus my equal to comparing, let me compare, comparing Lx plus my equal to 1 and this x upon twice a plus y upon y1 equal to x1 upon twice a plus 1. Now let me compare them. So on comparison we get, what do we get? Is L coefficient of x. Here coefficient of x is 1 upon twice a. So L upon 1 upon twice a is equal to y upon, sorry, m upon, because m is coefficient of y here, this m, so m upon 1 upon y1, y coefficient of y is 1 upon y1 is equal to this 1 upon this whole value, because this is x1 upon twice a plus 1 only. Okay, so L value, let me calculate taking this and this and this and this. So first let me take L upon 1 upon twice a is equal to that value, that means 1 upon x1 upon twice a plus 1. What do we get? So L equal to this whole value. This 1 upon twice a will come in the numerator. This implies that L is equal to 1 upon twice a upon x1 upon twice a plus 1. If I take this side to this and L to that side, or it will give us twice a, let me take here twice a, divide it by first L equal to, therefore 1 upon twice a to this, that side, it will be x1 plus twice a only. Why? Because multiply by twice a to the numerator, sorry, denominator. We will get x1 upon twice a cancel out, and plus twice a. Therefore, L is equal to, or sorry, x1 equal to, we have to find out value of x1. This implies that x1 plus twice a is equal to 1 upon L, or x1 is equal to 1 upon L minus twice a. This is the value of x1. Okay, let me write here. So what we obtain here, so we have obtained x1 equal to 1 upon L minus twice a. 1 upon L minus twice a, value of x1. Now we have to find out value of what is y1. For y1, this second ratio, this and this we have to take, and m upon 1 upon y1 is equal to 1 upon x1 upon twice a plus 1. Now solving these two. So for y1, let me solve it. What the value of y1 in this case? Take 1 upon y1 to this side and this m to this side. Now substitute first. Let me take value of x1 here. It will be m into y1. This is nothing but y1 in the numerator. Take it will be m into y1 equal to this value. 1 upon x1 is this value. So x1. Okay, let me take the LCM here twice a. It will be x1 plus twice a upon twice a. This is equal to twice a upon x1 plus twice a to the numerator. This is the value of solution of this. Okay, I mean solution of this only after taking twice a LCM. So now substituting value of x1 here, what do we get? This is twice a upon this value of x1. That means 1 upon L minus twice a plus twice a is already there. Use twice a cancel out. This is nothing but twice a L. Take L to the numerator, or divide twice a by 1 upon L, or convert division sign of 1 upon a into multiplication. So it will be L upon 1. That means twice a L. This is value of this. So y1 therefore is equal to twice a L upon m. This is value of y1. Okay, so y1 is this value. That means twice a L upon m. Now if I substitute these two values in this equation, second one, so we will get this condition. What is the required condition? Let me put these two values. So we get y1, that means twice a L, okay, upon m whole power 2 equal to 4a into x1. Now x1 is this 1 upon L minus twice a. Okay, so that means let me first solve it. This is twice means 4a square into L square upon m square equal to 4a is 4a into 1 upon L minus twice a. Now let me take m square to the side of 4a is cancelled out. 4a, 1a is cancelled out. That means a L square is equal to m square into this 4. That will be m square upon L minus twice a m square. This AL square is left here. 1a and 4a cancel out. Okay, this, and if I divide by 4a, both the sides, this 4a and this 4a, only AL square will be left over here. So this m square take to this side, left and right hand side, cross multiply. So m square upon L minus twice a m square. Now therefore take LCM L here. It will be m square minus twice a L into m square upon L is equal to AL square. Cross multiply this. It will be AL cube is equal to, or take this. Okay, let me write first as it is. Minus twice AL into m square. Now solving it further. So we get AL cube plus this negative part, okay, this part of this left hand side. If we take from left hand side, it will be positive. So twice AL m square is equal to m square. This is the, I think, okay, condition, okay, proved. The condition is proved. So this is the condition we have obtained. So final condition is obtained. Hence it is proved. Hence it is proved. Hence proved. This is proof. Okay, so in this way we have to prove if condition is to be found out, if the normal is given, and we have to calculate one and the normal and then find the condition. Condition can be easily obtained then. Okay, but let me take the sixth question. Question number 6 says, if ax plus by, again of the same type, I think, equal to c, is a normal. Okay, this is the normal. Is a normal is of the same type. The normal of the curve, this curve to the curve. Okay, this curve is an minus 1 into y is equal to x raised power n. To the curve, this is the first equation of the curve. The curve, then prove that, then to prove, let me write here, then what we have to prove here. To prove, then n raised power n, capital A raised power n, c raised power n minus 1 is equal to a raised power n minus 1 into b, little bracket, n a square plus b square, okay, whole power n minus 1. This we have to prove again of the same type. First find out derivative, then find the equation of the normal, okay, then compare these two normals, the given normal, what the equation given to us, this is one, ax plus by plus equal to c, and then, okay, find the condition. So we have to find out that condition. Now let me solve it. So differentiating the equation, the curve here, differentiating first with respect to x, we get, differentiating first with respect to x, we get, so this is constant an minus 1 as it is into d by dx equal to n into x raised power n minus 1. So what do we get here? D by dx is equal to n into x n minus 1 upon a raised power n minus 1 is the value of d by dx. And if I take x1 by 1 as a point, let x1 by 1 be the point. Okay, then, or it can be taken as x by, no problem. So then the equation will be, okay, what will be the equation then? N x1, this will be then n x1 whole power n minus 1 upon a is constant, a n minus 1 as it is. This is at the point x1 and by 1. So therefore equation of the normal, equation of the normal to the given curve, will be d by dx into y minus small y plus x minus small x equal to 0. Substituting value of d by dx, which is this value, this is n into x raised power n minus 1. Take either 1 x1 divided by a raised power n minus 1 into y minus small y plus x minus small x equal to 0. Now let me further solve it. So this d by dx, let me remove, okay. So final differentiation value is this one, this equation of the normal. Let me solve it. So if I take this x1 to x1, this is y1 x1 point, and a n minus 1 to the y. So this will be y upon a n minus 1, y upon a n minus 1, okay, minus small y1 upon a n minus 1, okay, plus x upon n into x raised power n minus 1, okay, and this is minus sign x1 whole power n minus 1, sorry, x1 upon n into x raised power x1 raised power n minus 1, okay, equal to 0. Now let me further solve it. These two steps having denominator like this, and okay, so let me write it again. X upon n into x raised power n minus 1 plus y upon a raised power n minus 1 is equal to this x1 upon positive n into x1 whole power n minus 1 plus y1 upon a raised power n minus 1. This is the final equation of the normal, which we have obtained. Now this and this equation given, to be compared. This is, let me take third equation. So comparing the equation of normal and this normal. So comparing this equation with the given equation of the normal, with the given equation of the normal. So we get here a upon coefficient of x is a. Here it is coefficient of x is 1 upon this. It is 1 upon n into x1 whole power n minus 1 is equal to, okay, this is b, coefficient of y, b upon this 1 upon a n minus 1 is equal to, there is c, so c upon these two values. They are not 1 upon but x1 upon n into x1 n minus 1 plus y1 upon a raised power n minus 1. Okay. Now let me take this ratio to this and this ratio to this separately. Then values of x1 y1 are to be calculated from these two. That is the final aim of this equation. So let me help them and solve them completely. So what is the next step? This we have to prove whatever this, that for that we have to find out value of x1 by 1, then substitute that x1 by 1 value in this equation, which is a n minus 1 into y1 equal to, and since this point is line, this one y1 equal to x1 whole power n. This we will substitute here, the value of x1 by 1 in this equation. This then solution can be obtained. This condition can be obtained then. Let me take the first ratio this and second this. So that will give us a upon 1 upon n into x1 whole power n minus 1. No need of writing 1 or something. Just x whole power n minus 1 is equal to c upon x1 upon n into x1 whole power n minus 1 plus y1 upon a raised power n minus 1. Let me solve this. And here the second part is that, let me write here 1 upon a raised power n minus 1 equal to the same value c upon n, c upon x1 upon n into x1 whole power n minus 1 plus y1 upon a raised power n minus 1. So these two parts we have to solve. Now let me remove it. Okay, so first from this ratio, what do we get here? If I take this a upon c and this two numerator, so this is a upon c, what do we get here? In the numerator we are having 1 upon n into x1 whole power n minus 1 divided by this whole value. This is x1 upon n into x1 whole power n minus 1 plus y1 upon a whole power n minus 1. Okay, if I take this n into n minus 1 in the numerator, so what it will be? So let me check what it will be. This is 1 upon, if I take this denominator to this, multiply to this denominator of the numerator to the denominator. Okay, so multiply this by this, we will get only x1 plus, because this n x1 power n cancel out, this and this will be cancelled out. This is plus y1 into n into y1, okay, into x1 whole power n minus 1 upon a n minus 1. This is a1, sorry, a n minus 1. Now if I substitute value of y1, what is that? Now y1 is